Namaskar, my name is Dr.suresh. I'm currently working as lecturer in the Department of Commerce and Management Studies, Kendrapada Autonomous College. So, there is a subject in NAP 5, fifth semester. Uh, the subject is Business Data Analytics, and there is a chapter called Data Cleaning and Pre-Processing Techniques, in which the one of the most important topic is how to handle the outliers. Okay, so today's topic will be on that how you are going to handle the outliers. So if you'll see this, I'll just try to magnify it. Okay, okay, done. Then you can see that some values in a data series might be, extreme, and these are abnormal. If you'll see the data series, the values are quite high or quite less. Then such type of values which are not near the average value, you can see that can be treated as outlier. For example, in this you can see that if the data series 10, 15, 22, 330, 330, 45 and 60, clearly you can see that 330 is the outlier, and this deviates significantly from the other values in the data sheet. The question is the question is what are the different types of outliers. So if we'll see in this case that there is a global outlier. What is the meaning of global outlier? These are the points which or values which deviate significantly from the rest of the data in the data set. For example, here you can see that the number of customers who have visited mall in last 12 months, that is from January to December. You can see that in January it is around 15,000 customers who have visited. In February again around 50,000. March again around it is 13,000. Then May, June there is, and there is a slight increase in the month of September, October, November, December. But if you see the data of April, which is around 35,000 footfalls of customer, number of customers who have visited in April, this is significantly high from the rest of the data. That's why it will be treated as a global outlier. Similarly, if you'll see, there is another outlier called contextual or conditional outlier. Okay, sometimes also this value also differ, but they would not even be considered outliers because in a particular month there may be significant difference, but not that much that it should be out, treated as a huge deviation from that data set and can be treated as a contextual outlier. And if you'll see the sales of the company uh, in the month January to December, there is a there is increase of from January to May, and there is a steep, not steep, around for 162, there is a decline up to 120. Then again it has gone up, and again it has gone down. So this value that around 120 in the month of June is a contextual outlier, and see why it is. If critically examined, the sales have increased from January to May, and in the month of June, it has suddenly come down. But in the month of July, again the sales have gone up, and subsequently it has come down in the month of December. Here, the sales of June is a contextual outlier because it is not following the trend only, but the value is not significantly different. Okay, significantly that much different from the rest of the value. So thus, yes, because it is not following the trend, then it is treated as a contextual outlier. Okay, but in global outlier, you can see that it is significantly different from the other values. But in case of contextual outlier, the outlier, if it is not following a particular trend and there is a sudden dip or rise in a particular variable, then that will be treated as a conditional or contextual outlier. Similarly, there is a collective outlier concept where these are the marks which have been secured by some students, and you'll see that most of the students have secured between 50 to 90, whereas some people or some students who have scored between 20 to 30 marks, and this is a few people or few students who have scored, and this is a cluster, or you can say it is a collection of people that's or students who are, collectively they are outlier from the rest of the data. So this is collective outlier. Then we'll go for the mm, I'll see here also the example that we're going to cite is this one, where you can see 1 minute. Okay. uh, you can see that okay, this is the height of students, roll number from 1 to 21, and height is given from 1.68 meter to 1.65 meter, 1.82 meter, like this. And if you see the data, you can see that roll number 15 is an outlier because it is showing 8.5 meters of height, whereas most of the students' height are between 1.5 to 2 max. So this means that this value is an outlier. But again, you have to show it. So how to represent it? Either you can go for visual method or you can go for statistical method. Now we will go for first visual method. So visual method, see, if you'll draw that in a particular box whisker chart, you'll see that this value 8.5 is only the one outlier which is, not fitting into the box or not included in the box. So it is an outlier. Similarly, if you go for histogram with the same data, it is saying that around 20 students are there which are in between 1.65 to 3.55 meter, and only one student is there who is between 7.35 meter to 9.25 meter. So it is again another way of finding out outlier. Another form of finding out another plot is scatter plot, through which you can find out the outlier. Again, you can see that roll of 15 is having 8.5 meter. So this is a very huge difference from the other data. That's why it is not a contextual outlier because it is not showing a trend. It is just a global outlier. Okay. Again, if you'll go for statistical method, you can go for z square value. Not z square value. You can go for z value or z score value. Okay. So what is that? Now see how it has been calculated, z score value. And if you'll see the z score value of roll number 15, it is coming 4.35. What does it mean? Okay, what is the formula that we are going to, apply for z score? The formula is data value minus mean divided by standard deviation. Okay, so that means we have to calculate the mean of the data set. So the mean of the data set is, again, we have calculated is 2.140, and standard deviation of this meter height is 1.461. How it has been calculated? Now see, if we'll see the data, it is 1.682 uh, uh, 1.76. There are 21 students. Mean, again you will put the formula, average is equal to average 822 to 822. You'll get this value. Again you'll apply standard deviation formula is equal to standard deviation STDEV dot S. 822 822 is the number of sample that you have taken. S is sample. We are not taking P as because it is only a sample. So you'll be calculating the value of 1.461. Then you can calculate Z value. Okay. How to calculate? Again, you have to put the formula. A2 means the value minus mean A23 divided by A24. Okay. So by this method, you will be calculating the Z value, and it is 0 minus 0.32 like this. It is when you scroll it down, you'll get this value. Okay. And what is the conclusion? When z score value, if the z score value is more than 3, that means it is an outlier, and in the whole data series, only this 15 roll number which is having 8.5 meter, its height, his height is 4.35, which is higher than the standard z-score value of 3. So this is an outlier. If you go for another method of modified z-square, okay, so this is how it is calculated. Again, in this method you will be calculating median. Okay, so again you will be putting this formula. See, okay, first go through the formula. What is the formula? Remember that in case of modified z-score formula, z-score formula, it is 0.6845 into, okay, into xi minus m divided by MAD. Uh, MAD means median absolute deviation. How it has been calculated, whole calculation, I have done it in Excel so that it will be easier for you to calculate. So see how it has been calculated. Uh, so so the height is 1.68 up to, again I have copied it up to 1.76. Then again you have to calculate median. So you will put the formula of median. So median is equal to median D2 to D22. Same data has been taken here for modified z-score value. Then difference from median, so 1.68 minus 1.82. So we have calculated like that. Then absolute difference from median. So here it is difference. We have to take absolute difference, means all the negative values will be, obviously it will become positive value. So this is mod of the value. So this is how it has been calculated. And again you see that uh, okay, the it is coming 6.68, the absolute deviation from the median of roll number 15 whose height is 8.5. Now how it has been calculated, again we have to see that what is MAD. Okay, so median of F2 to F22 is the MAD means mean deviation from the median. Okay, I have given that. The formula is mean absolute deviation. Okay, median absolute deviation. So MAD. So again we will putting the formula. So 0.6745. Again we have put the formula here. Here we have taken this formula value here, and we have put this formula 0.6745 divided by H2, E2 is your this value, difference between median, difference between the value from the median, then into uh, D2. Okay. So for that we have again calculate the median value, and the median value, MAD value is 0.09. Okay. So how we have calculated is that this value is that, okay. So E2 into H2, E2 into H2, E2 is 0.14 minus 0.14, H2 is 0.6745, and divided by F23 is the MAD. median deviation, absolute deviation. So you'll get this value 1.04 minus 1.0492. How it has been calculated? Again, I will tell that E2 means the deviation of the value from the median into H2. H2 is the constant value that we have got for this formula, and then F23. F23 is the MAD, that is median absolute deviation. So it is 0.09. You will get this formula and you will get this value of minus 1.0492. Again, if you scroll it down, you will get this value, and you can see that it is 50.0629 of 8.5 meters. It is 50.0629. And again, if you see the guidelines, or if you see the rule, it should be modified z score value should be lesser than uh, 3.5. Okay, so if the value is more than 3.5, then that will be treated as outlier, and our value of 8.5 meter, we're getting the modified z score value of 50.62. So this is a clear cut outlier. Okay, so this is how you'll be calculating uh, the outlier or recognize the outlier. Thank you.